Hi, everyone. Thank you for coming today. I see people are still coming in. There's plenty of seats up front if you want to start filling in up here. My name's Casey Anderson. I'm the program manager for the Visual Studio Debugger, a part of the broader diagnostics team. We handle profiling, debugging, IntelliTrace, historical debugging. And today, you all are sitting in the room for the Debugging Tips and Tricks talk for .NET developers in Visual Studio 2015. So if you didn't mean to be in this room, stay anyways. This is going to be great. So here's my clicker. I just threw a couple quotes up here for you guys to read. And I'm going to guess one of the reasons that you're in this room is because you have to debug issues in your code on a daily basis. Now, you probably don't get paid to debug. You probably get paid to write new code and introduce new functionality that you will later have to debug. And our goal is for the Visual Studio Debugger is to provide you with tools and features to help you find and fix your issues as fast as possible to get you back to your moneymaker, which is writing code, right? So today, as we tour through the debugger, I hope everyone can be introduced to at least something new to add to your debugging tool belt that you can take back to your day-to-day job and use it frequently to help you find and fix your issues faster. Now, just the agenda today. Welcome. Welcome. I'm glad you're here. Especially after lunch, you're all well fed, so I know you're going to be happy and not hangry. We'll go through demos today. I'll show you 30+ tips and tricks as we go through 4 demos in the Visual Studio Debugger. And then at the end, toward the end, I'll show you 2 new things that we're working on for Visual Studio 15 Preview, which is available for you to download. And last, I'll throw up some resources on the slides for you to look at, and also give you some opportunities to provide us feedback at the end. So let's go to my first demo. Can everyone see this okay? I see heads nodding, great. So I have this WPF application here. And we get asked to present this debugging tips and tricks talk at various conferences, and I like to use this app. But because I obsess over my customers, which is all of you guys, I like to greet you personally. Now, I could hard code a greeting into this application, but instead, what I can do is pass command line arguments into my WPF application so I don't have to edit the code for various audiences. I can do that. I haven't done that yet here. That's why it says hello, provide conference argument. I can go to my project properties for my WPF application by right-clicking on projectarchive.wpf and going to the properties page. Before I enter my command line arguments, I want to point out a couple other things about the project properties page. There's multiple start actions that you can configure from here. You can start this project, which is what we're doing now, or start an external program. This is really great if you're doing something like developing libraries or even Office extensions. So you can choose to start, for example, Excel, and then when your code gets called, you'll start debugging that when it's triggered. I also want to point down here to enabling different debuggers. You can also enable native code debugging, SQL Server debugging from down here in the project properties page. But what I wanted to do was show you how to pass in command line arguments. So we just have this box right here, and I'm going to provide my conference flag. And then I want to greet you personally, right? Who are you guys? You guys are my build peeps. And now when I start debugging, I'm expecting that application to say, hello, build peeps. But instead, what it's saying is hello conference. So there's a bug in my logic somewhere. Now I'm going to debug into that to figure out why this isn't saying build peeps. So notice I don't have any code open. I could navigate through Solution Explorer to try to find the entry point for this application. This greeting's getting set on startup, and I'd have to navigate around to find it. But did you know that you can start debugging by stepping directly into the entry point of your application using step into or step over. Both of them have the same effect. So I'm going to step over, and you'll see that the debugger lands me at the entry point of my application. So now I can continue stepping using F10 to look at my logic, to see what's happening. And I just stepped over the line that made my greeting for me. And I'm concatenating a bunch of different function calls to produce this greeting that says hello conference. Do you ever wish that you could see what these different function calls returned while you're debugging? I know I do. And the good news is that using Visual Studio, you can. To the locals window. In the locals window, you can see right here that I have my different functions and their return values. So I can see that get conference returned conference, get punctuation returned exclamation point, get greeting returned hello. Because of this, I'm clued in now that get conference is actually my wonky method, so I'm going to go debug into that one now. I've already passed this line of code, and like I said, this is on the startup path, so I could stop debugging, restart debugging, set a breakpoint, do that, but instead, I can be more efficient here by using a feature we call set next statement in the debugger. Does anyone here use set next statement? That's a lot of hands. That's good. This is one of my favorite features. It makes debugging, makes changing the execution flow really easy. So I can right-click on a line of code that I want to go to, which would be 200 in this case, and I can choose to set next statement, which keyboard shortcut is Control-Shift-F10. Or alternatively, I can just grab the instruction pointer and drag it to different places in my code to set the next statement. So I just dragged it to line 200, and that means that now when I hit continue or F5, that's the next line that's going to get executed in my application. We didn't change anything about the memory, so you can see that all of these values are still there. But now, when I would step into get greeting in this case. But we already decided that get conference is actually the area that I want to debug into. So I could F12, go to definition for get conference, set a breakpoint there, and hit continue. Is that a common workflow a lot of you do in situations like this? I see a lot of head nods. Did you know there's a feature in the debugger that you can find by right-clicking on that line of code with multiple function calls? And it's called step into specific. So what this option does is it lists out for you all of the function calls on that line that you could potentially step into. In this case, I want to step in to get conference. So when I click on this now, it's going to land me on the first line of the get conference function. And I didn't have to step through get greeting or set a breakpoint. Awesome. OK, so now my microphone just fell. 1 second, ladies and gentlemen. Let me reattach that to my shirt here. Wonderful. Can you still hear me? Great. OK, so now I've stepped in to get conference. My microphone's on my shirt, and we're going to keep debugging. Now, I see here that this is where I'm setting my conference parameter. I could step over all of these lines of code to get here, or what I can do is right-click again and go to this feature called Run to Cursor. This is one of my favorite features to use when I need to skip over large chunks of code just one time while I'm debugging. I don't need to set a breakpoint, hit the breakpoint, remove the breakpoint, or just sit there going F10, 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 F10. I can use Run to Cursor. So its shortcut key is Control-Shift-F10. And when I click on this now, my execution pointer is going to run to line 158. And you can see that that just happened. So now that I'm down here on line 158, I'm inspecting my arguments. Conference is my first argument. Build peeps is my second argument. But I can see that I'm setting conference to be my first argument, and I really want it to be my second. So I'm going to use a feature now called edit and continue in the debugger, meaning I don't have to stop the debugger to edit this code and see the updated values. I can edit it under the debugger. So I'll add +1 here. And this line hasn't executed yet. So now as I step out of this function, meaning that it will finish executing and land me back on my previous line, so now I've stepped out, and that should fix my issue. Now, while I'm here, I will just continue stepping. So you see that step out landed me back at 200 at the end of get conference, but we still have get punctuation left. So when I step in, I'll step in to get punctuation. And if I continue to step in, I'll step in to get exclamation. And now I'm down here in get exclamation. And in order to go back up to line 200 to continue debugging, I would have to step out, step out, step out. You can see this in the call stack right here. Or that run to cursor feature I mentioned before, you can use in the call stack. So when I right-click on the stack frame that I want to step out to, I can choose run to cursor, and it'll bring me back out of all of those function calls and back to line 200 in this case. So this is really useful if you're 6 or 7 or 8 layers down in a function, you find your issue and you just want to get back to where you came from. You can use run to cursor from the call stack to step out of multiple functions at one time. So that's a lot of different ways to navigate your execution control through the debugger. And when I hit continue, you can see that I'm greeting you properly now. So hello, my build peeps. Now, before I jump back to do a recap, I want you to notice something here. I've stopped the debugger. I have the string utilities class that I'm working on. And in this string utilities class, it's a static library that I'm building up as part of my shared code. And I want to just test out this method I've been working on called reverse string. Did you know that you can use the immediate window during design time to build up state and execute code? Raise your hand if you've ever used the immediate window during design time. Very few, but still more than I thought. So this is one of my favorite ways to test library code. So normally I could wrap it in a test harness, but in this case I don't have to. So I'm going to build up a state real quick, and it's a string utilities, so I'm going to make these strings. My first string will be hello, and my second string will be it's me. And I hope that's stuck in your head for the rest of the day. So now you can see that I'm building up state right here. A is hello, B is it's me. And I can call into my string utilities class, string utilities, and my reverse string method. And I can call that on A here. And I can execute this. Now notice that it doesn't have debugging. We're not in debug time. But now I am in debug time because I have a breakpoint set in my return string method. So you can actually use the immediate window during design time to execute library code and hit breakpoints in that code. And since I had 2 strings, I just want to show you right now that the immediate window is still active. So I can actually call string utilities dot reverse string on B, and it's going to hit that same breakpoint, but now in B. And you can see this in the call stack real quick, that there's a transition here. So I'm stopped at this stack frame for A, and then I executed new code in the immediate window, and it also has the stack frame for the next breakpoint. So we support nested breakpoints, so you can use the immediate window like you use it during debug mode, even when you start from design mode. So when I hit continue now, it's going to finish B first, so it reversed that string. And when I hit continue again, it'll finish A. Perfect. So that's a great debugging tip on if you're dealing with library code. You can use the immediate window. So now I'll just recap real quick what we talked about. A lot of execution control and the immediate window. And we're going to do this for about the next 45 minutes. Does that sound good to everyone? Wonderful. Let's get back into Visual Studio and move on to my next demo. OK, so I'm greeting you properly. And what this application I'm writing with my colleagues is actually supposed to do is we're building it to get an inventory of apps, sample apps, that we present at conferences like this one. Ultimately, we'll end up connecting to a web service to retrieve the actual information, but for now, I'm building it up, so I just want to test the loading of my data. So I have hooked up some code to my load data button, and now I'm going to test that data. You'll notice that I stopped in the debugger without having a breakpoint set. I did this using a feature called debugger.break. It's a hard-coded breakpoint that you can put in your code to stop under the debugger. This is really good if you have an application that has a bug down an execution path that maybe doesn't get called that often. But when it does get called, you definitely want to break, and you want to be in a reliable way. So you can enter a debugger.break into your code at that point, and while you're going through the rest of your daily debugging activities, whenever that code path gets executed, you'll break. It should be noted that a debugger.break is actually throwing an exception in your code. It's actually throwing an exception. So the reason you can see now that I have it wrapped in a debugger.isAttached. And when I've wrapped the debugger.break in the debugger.isAttached, this will handle it properly. So if I didn't have debugger.isAttached and I didn't have a debugger attached, I would have crashed my application. You can also use debugger.isAttached to, you can use if debugger.isAttached to execute different code paths. So you can put anything you want in between here. If you want to add more logging when the debugger is attached, you can use this code. If you want to execute a different code path when the debugger is attached versus when it's not, you can do that by wrapping it in this if debugger.isAttached. OK, but why did we come here? We came here to inspect the loading of our data. So I'm going to look at my data provider here, open the data tip. I see I have a bunch of different types of data, and this data tip isn't necessarily super useful to me right now because I can't really make sense of these strings. The good news is that we have 6 debugger visualizers built into the product that will help you view this data in a manageable way. You can access the debugger visualizers by clicking on this magnifying glass next to the object or the data type. This magnifying glass appears in our locals, autos, watch window, and also the quick watch window. So when I click on it, you'll see the list of visualizers available. We've got the text visualizer, which will show you all of your text, and you can copy and paste from here and view it in an easy way. We also have introduced the JSON visualizer. So this is a JSON visualizer. And you can see that it's nicely formatted, this text, so I can view it in an easy-to-read way. I can also search through here. So if I want to see all of my app IDs, I can search for that, and then the visualizer will support search, and I can quickly examine my data this way. Another visualizer we have is the XML visualizer. Just wanted to open that up so you can see that it shows your XML. Also the HTML visualizer, which will render your HTML. And lastly, in this data tip, I want to show you the dataset visualizer. So the dataset visualizer will display your data in a nice, easy-to-read table with rows and columns, and you can change your table in here. And this is just a great way to visualize your data sets if you have a lot of databases that you inspect frequently. And I mentioned 6 visualizers. So the last visualizer I wanted to show you was our WPF visualizer. So this is my WPF element. When I click on the visualizer, I can open the WPF tree visualizer. In the tree visualizer, you can see the list of elements that you have. And as you select them, you can see the rendering of that element in this window, and it'll give you the list of properties that that element has. So those are the 6 visualizers we have in the box, but it should be noted that visualizers are an extensibility point of the Visual Studio Debugger. So if you deal with a certain object frequently and you want to write a visualizer for that, the documentation is on MSDN, and we also have several visualizers available in the Visual Studio Gallery. So I encourage you to go look around in there and see if anything will meet your needs. As we keep inspecting our data here, I'm going to look at my apps, my list of apps here. And similar to before, this data tip isn't really giving me information that is digestible for me. I would have to drill into each of these apps to make sense of what this list is, what items are in this list, because it's just showing me the object type right now. And I can actually change what the debugger shows me by using an attribute called the debugger display attribute. Has anyone ever heard of the debugger display attribute before? OK, very few hands. So the debugger display attribute, I can add it to the object type. And I'm going to do that now by first navigating to the object type. I could F12 to go there, but I'm going to use Alt F12, which opens the peek window. And Alt F12 is peek definition. So now without context switching my code files, I can be inside of this class to add my attribute, and it opens in this peek window right between the code. So the attribute I wanted to add is the debugger display attribute. And I'm not getting IntelliSense here. I can use control dot, which triggers the light bulb, and I can hit enter because its first suggestion is using system.diagnostics, which is what I want to do. So I control dot to enter that, and now you'll see that it works with IntelliSense. I'm going to now tell it what string I want to display. I want to display the app, and I'm going to use curly braces to evaluate one of the properties of this app. So in this case, I want to evaluate the app ID. I can't remember if it's uppercase or lowercase, so I'm going to hold the control key, and it's going to make this transparent so I can see through it. And I can see now that app ID is uppercase. So you can use control when there are certain elements in the editor that you just need to peek through real quick. So I can see that it's app ID, and I've put that in my curly braces. And this purple line is telling me that I have to restart the debugger to have this take effect. So I'll go ahead and do that, click load data again, and then we'll inspect our list of apps to see how the debugger display attribute has changed them. I can close this now that I don't need it anymore. And when I inspect my list of apps, you can now see that the debugger display attribute shows me app and then the app ID. Now, when we're going through the debugger, we look for the debugger display attribute first. And if we can't find that, we'll look for toString to display here. And then we'll fall back to the object type. Great. So now I've made a list. And so now I can make sense of this list. Let's keep inspecting the data here. I'm going to put a breakpoint down here and run to it. Now, in this for loop, I want to inspect the language of each app. So I know that this is app 0, because I can see it there, and I want to inspect its language. So I'll step over this, and I'll go hover over language, and it'll say C#, and then I'll hit continue, and I'll see the next app, so on and so forth through this entire loop. Now, if I don't want to hover every time, you can use a feature in the debugger that's especially great for loops, where you can pin this data tip. So everyone see this pin icon right here to the right of the data tip? When I click that, it'll pin to my editor. So now when I continue through this loop, it'll update in line, and I don't have to hover every time or look away to the watch window. I can see it right in my code. I can also, thanks, one person clapped. Thank you, I like clapping. Feel free to clap for me anytime. So I can also add expressions to the data tip here. Like I said, I was interested in the language. So there's a property on my app called display languages. And I can add that to the data tip. So now it's really easy. As I'm going through this loop, I can start to see my apps and their languages, and I don't have to hover or look away from the code. So that's what pin data tips are really good for. If you prefer to stick over in the watch window, of course, we support that. So I can type app in here, and it'll evaluate. And now that I'm here in the watch window, if I step in to get languages, mini quiz. Does anyone know what will happen to app? It gets grayed out. And if I hit refresh, it can't find it. Because while that object, app6, exists in memory, its name doesn't exist in this get languages for display method. So if I want to inspect that object as I'm stepping through, how do I do that? You can use a feature in the debugger called make object ID. Has anyone here ever used make object ID? Very few people. When I right-click on this app, you can go and select make object ID from the context menu. What this is going to do is it's going to give you a handle to this object type. In this case, it's app6, and I can reference that using $1, and I can add that to the watch window. So now when I step into Get Languages, even though app is no longer valid, I can still inspect all of the properties for app6. So that's a great tip if you need to inspect objects across functions that are in memory. And when you're done, we recommend going ahead and deleting that object ID because there is some overhead to maintain them. Great. So with that, we just showed a lot of different ways that you can inspect variables while debugging. Are there any questions at this point? Sure, go ahead and come to the mic. It's not on? Nope. Do you want to come closer? Great question. So his question was, is there any way to have a conditional sort of like breakpoint where you can break when the object ID changes? Currently, no, there's not a way that you can do this, especially in .NET. For C++, we have this thing called data breakpoints that will break the code when the value changes, but we haven't implemented that yet for .NET. Yes. So the first part of your question was, if the debugger is attached, you have it. Yes, you show the debugger.break and check to see if the debugger is attached. Okay, so he's asking for clarification. If you don't have debugger.break wrapped in debugger.isAttached, what will happen? Is that your question? Will it break or will it crash? Got it. So if you don't have a debugger.attached, if you don't have an actual debugger attached and you hit a debugger.break in your execution path, your app will crash. If you are running under the debugger and you don't have it wrapped in debugger.isAttached, you will still break in the debugger and not crash. Does that clarify that for you? So the debugger display attribute will only take effect when the debugger is attached and only in our debugger display windows. Yeah, I have time for one more question. If he asked what happens if you build in release mode and forget to remove debugger.break, the app will crash when it gets to that line of code. That's a great suggestion. I hope everyone heard his suggestion was, can we get a debugger.break when attached to simplify that process down for you so you don't risk crashing your application, right? Exactly. I'll put it on the backlog. Okay, I'm going to go ahead and move on to the next demo, but we'll have time for questions later at the end. Go ahead and delete that. Get rid of my breakpoint. Okay, so I'm greeting you properly. My data's loading. What's next for me? In building up this application, I eventually will want to query my apps by type. So I have some library code that does that for me, and now I want to test it. So I've written tests to make sure that's working correctly. I'll run those tests now. Web is passing, mobile is passing, but whammy, desktop failed. I should be more surprised, but I'm not. My desktop test failed. And now I'm going to go to the library code where this is getting called and debug into that. So over here in get apps by type is where the code running these tests is getting called. I'm going to set a breakpoint here and run my tests again. Web pass, mobile pass, desktop failed. When I hit this breakpoint, I can see that my type is web, but web was passing, so I don't really care about inspecting this run through the method. And I could hit continue until I get to a desktop type, but instead what I can do is set a special breakpoint, a conditional breakpoint here, where when decoded type equals desktop. I can do that. You'll notice when I set this breakpoint in Visual Studio 2015, this toolbar now appears, the breakpoints toolbar. You can enable and disable a breakpoint from this toolbar, as well as open the breakpoint settings. And when I open the breakpoint settings, you'll see a peek window open up, similar to the peek window I showed you before. You can set conditions and actions on any breakpoint, and you can combine those. So we have 3 types of conditions currently available for the debugger. A conditional expression, which is what I actually want in this case. I can put anything in this text box that evaluates to a Boolean expression. So in this case, I care when decoded type, and you'll notice I'm also getting IntelliSense as I type here, when decoded type equals desktop. And now I can hit enter, my condition gets saved, and I can hit continue and go through this. We also have 2 other conditions that I could add. We have a hit count condition. Hit counts are great to use in loops. So for example, if you have a problem that occurs on the 105th iteration of your loop, it's a pain to hit continue 105 times, right? So instead, you can set a hit count condition where hit count equals 105. And then the debugger will pass that breakpoint up until the 105th time, and then you'll break into your code right where you need to be. The last condition type we have is a filter condition. Filter conditions are great when you're doing multi-threaded debugging. You can filter by machine, process, or thread. And when you do that, you'll only stop on this breakpoint for whatever you specified. So if it's a thread name, you'll only stop on threads with that name. And we have actions as well. We currently have 1 action that you can perform, which is to log a message to the output window. When you log a message to the output window, there are 3 types of text that we will print out for you. There's plain text, which will get printed just as the words you type. We can use curly braces like we did before, and whatever you type in curly braces will be evaluated, and then the value of that will be what's printed. And the third thing you can do is you can use the $sign to reference pseudo-variables. So we have a rich supply of pseudo-variables here for you to use. You can use, for example, function, which will print the function name that this breakpoint resides in. And I wanted to point out that by default, we have this box that says continue execution. What this does when you set this condition is turns this breakpoint into a trace point. So if you're not familiar with trace points, what happens is that when the debugger gets to that line of code, we'll dump the message to the output window and continue without stopping you under the debugger. So it's kind of like console.writeLine, but you can use breakpoints to set that up for your debugging purposes. OK, so I have my conditional breakpoint set, decoded type equals desktop. And now when I hit continue, you'll see that that breakpoint condition worked, and my decoded type now equals desktop. And I want to investigate what's happening, why this desktop test is failing. So I'm going to do that here in the immediate window. I just want to see right now what applications I actually have in my data set. So I'm going to type down here data.applications.select a in a.apptype. And I'm going to dump this out to, and I'm going to say distinct. OK, before I do this, Does anyone know, can anyone remember what happens when I try to evaluate this in versions prior to Visual Studio 2015? Yes. Yes, it will say unable to evaluate Lambda. Well, people, it's 2016, am I right? And this works. So yes, we have Lambda support in both our watch windows and our immediate window. And I love it so much, I'm going to use it again to investigate my issue. Now that I see what applications are in my application set, I am noticing that desktop here has a capital D, but desktop here has a lowercase d. And could my issue be that simple? Let's find out. Before I edit my code and continue, I can test out my fix using the immediate window. So I'm guessing right now, if I were to count the elements of type desktop, it'll be 0, and it is. Because I'm not I'm caring about the case. So what I want to do is test out adding an ignore case. So I'll do system string comparison, ordinal ignore case here. And I'll hit enter. And I'm hoping, yep. So now when I ignore case, I'll actually get applications of type desktop that'll return. This is great that I use the immediate window to test out my fix without having to run my code again. And now I can just copy my fix right from the immediate window and put it into my code. And using edit and continue, so I can edit this Lambda expression in my code and now hit continue. And my desktop test is passing. Woohoo! I love it when my tests pass, don't you? Yeah, I love it when my tests pass. At that point, I always take a deep breath and go, OK, that feels good. So now the next step is to do it for real. So I want to load all of my apps for real. So by talking to my web service. So I'm going to click Get Apps. And foobar, an error occurred contacting the server. In this case, I'm realizing that we have just been testing library code up to this point, and we haven't actually started the web service. So all I need to do is go start the web service. Did you know that in Visual Studio, you can set your solution to launch multiple projects at a time on F5? I can configure that by going to my solution properties. When I right-click on solution and go to properties, you'll see that right now I have a single startup project selected, which is my WPF application. And I can change this to now do multiple startup projects. So I can start my web service with or without debugging. I don't need to debug it in this case, so I'll choose to start it without debugging. And I'll continue to start my WPF application. Now I'll hit OK. And I'll need to restart to get that web service to spin up. So I can do that with the restart button here on the toolbar. So now when I click Get Apps, I expect it to load all my apps. And it does. Perfect. So now I have my apps loaded here. I can look through these. Let's say I just care about mobile types. So I can load my mobile types. Let's load my mobile types. Oh, forgot to remove some breakpoints from earlier. And I'm noticing a bit of a slowness. Can you guys see that blink with me? It feels really slow when I'm clicking this. So I'm going to go investigate where that slowness is coming from and see if I can do anything about it to make that faster. Get Apps feels pretty fast. Mobile feels slow. So I'm going to go into the load by type click handler and set a breakpoint, load it again, hit my breakpoint, and you'll notice that to the right of the line of code that I just stepped over, you'll see this little gray number appear. We call this a perf tip. And what this is a really good approximation for how long the code took to execute from break state to break state. So in this case, I stepped from 261 to 262. And I can see from the perf tip, it says that took less than or equal 1 millisecond. It says less than or equal 1 millisecond because the perf tip is an upper bound. I know that it took up to that amount of time to run. Perf tips aren't necessarily accurate down to the milliseconds, so 4 milliseconds is not 4 times faster or 4 times slower than 1 millisecond. But they're good for order of approximation. So if I step over a line that takes 100 seconds and a line that takes 10 seconds, I know that that 100-second line is actually slower than the 10-second line. So I can keep stepping through this and looking at my perf tip, but I can also run from breakpoint to breakpoint or break state to break state, like I had mentioned before. So I'll show you that right now. If I set a breakpoint on the end of my function here, when I run, this perf tip now tells me how long all of this code in between here took to execute. And I don't expect it to be this long, actually. So I'm going to start stepping through this method to see where the bulk of that time is. So I'll drag my instruction pointer up, and I'll step over each line of code, glancing at the perf tip as I go through. When I step over this line of code, I notice that the perf tip is significantly bigger. So I'm clued in that this is where the majority of my time in this function is being spent. I can see that I'm getting my server certificate from the web service, but I would expect that to be cached once I do it the first time, and I've called this several times now. So I have an inkling that that's not happening. So I'm going to step into this method, get server certificate. OK, as I step over, I can see that I'm checking to see if it's in the cache, but I'm not finding it. And when I look through the rest of this method, I'm realizing that I simply forgot to add it to the cache. In this case, that's the certificate store. So I will add a line of code here, certificate store.add, and our key is the base URL in this case. And on the line above, we'll see that I do get the server certificate from the web, so let's just cache that value. And now, when I hit continue, I'll run to my breakpoint down here. And you can see now that we've cached it, when I run this again from breakpoint to breakpoint, the time reduced significantly down to 7 milliseconds. So using that perf tip, I was able to be clued in to a part of my code that was taking longer than I should, and then I was able to validate, using that same perf tip, that whatever change I made actually knocked time off the execution clock. So perf tips are new in Visual Studio 2015, and I encourage you to pay attention to them and try them out. Another tip about perf tips is that you can actually click on them to open the diagnostic tools window. Has anyone here ever heard of the diagnostic tools window? Raise your hand if that sounds vaguely familiar. Quite a bit of you, actually, which is great. Raise your hand if you've ever closed the diagnostic tools window. Even more hands than the people that have seen it? I'm just kidding. The diagnostic tools window is actually a really great thing to have while you're debugging performance issues in your code. And the perf tip is a way that you can get it open without having to navigate through menus. So when I click on the perf tip, it'll open the diagnostic tools window. So now I have, where'd it go? So it'll open the diagnostic tools window. And I'll briefly mention some things about the diagnostic tools window here. You can see in the diagnostic tools window, we have a memory graph and a CPU graph. I'll unset my breakpoints here and continue so you can see these graphs tick along. So a memory graph and a CPU graph. And then I have 2 tabs down here. One that corresponds to memory usage, where I can take snapshots and then compare values. And I also have the CPU usage tab, where you can enable CPU profiling to see a breakdown function of CPU usage by function. So my colleague Andrew, who's actually sitting right up here in the front row, is going to be giving a session tomorrow. Let me get to the slide. Is going to be giving a session tomorrow called Become a Visual Studio Power User right here in this room at 6:30. And if you're interested in hearing more about the diagnostic tools window and all of its many capabilities, he'll be going in depth on examples of that. So I encourage you to be here tomorrow at 6:30 to hear how to use the diagnostic tools window to help you debug faster. Because we all want to be Visual Studio power users, don't we? I know I do. So let's go back to this demo here. What's next for me? I see my next button is my error button. And when I click error, I get an error. And it says that an error occurred contacting the server. Now, my guess is what's happening is that there's an exception that's being thrown and then caught, so handled, in my code by a try-catch. But it's not being dealt with properly, which is why I'm getting this error back. So I can since I have the diagnostic tools window open right here, I'm going to use it to verify my assumption about the exceptions being thrown and caught. When I click error, I want you to notice the events track on the diagnostic tools window. This events track corresponds to IntelliTrace events. So IntelliTrace is a feature we have in Visual Studio Enterprise that records a list of events here that you can view in the Events tab. And it also has historical debugging. So now I click error, and you can see this red diamond that just appeared in the events track. This red diamond is telling me that an exception is being thrown and then subsequently caught. So now using IntelliTrace, I verified that an exception is the root of this issue. I can use now historical debugging to go back in time to the place that that exception was actually thrown without having to restart my application again. I can double-click on this exception thrown event or click Activate Historical Debugging. And what that's going to do is it's going to take me to the line of code at the time that that exception was thrown. So here, it's taking me to line 22. Excuse me. We also have debugger windows that participate in this historical debugging functionality. You can see that those are tagged with the historical debugging tag. If I open the locals window, it'll have the exception in here and my exception message, which is unable to connect to the remote server. So that's one way that you can use IntelliTrace to debug exception issues in your code. How many people here don't have Visual Studio Enterprise? Okay, so let me ask it the other way. How many people here have Visual Studio Enterprise? Oh, quite a bit. Okay, that's wonderful. So if you don't have Visual Studio Enterprise, or you don't prefer to use IntelliTrace, how do you solve an exception issue like this? You could go and uncomment or comment out all of the try-catch statements in your code and wait for the debugger to break, but instead what I'm going to do is tell the debugger to break when certain exceptions are thrown. I can do that by going to the Debug Windows Exception Settings. Also, all of our debugger windows are under Debug Windows, not found in the View menu. So if you're looking in the View menu, you're not going to find them. When I open my Exception Settings window, this used to be a modal dialog that took a long time to open. But now it's a tool window that has a respectable search that I can use to tell the debugger to break when certain exceptions are thrown. So I'll click here next to Common Language Runtime Exceptions, which are .NET exceptions. And now I've told the debugger that whenever a .NET exception is thrown, break. When I click this error button now, the debugger breaks me on that line of code that we had saw with IntelliTrace before, but now it's real time during debugging, where I can inspect this URL and see that localhost is there, but it's not valid. And I can get more information in this exception assistant. So that's one way that you can use the exception settings window to debug exceptions as well. While I'm broken here on this exception, you'll see that I'm inside of an async task. So real quickly, I'm just going to show you the call stack window. And something we've added to the call stack window is this frame here that says async call. What we're showing you in the call stack window right now is the logical call stack. So you can see that get bad URL click made an async call, and get apps from web made an async call, and now we're in webutilities.get, which is the async method. So that's an easy way to orient yourself when you're dealing with asynchronous calls. Also, another pseudo frame we have here is the external code pseudo frame. And external code right now is hiding all of the non-user code from you. So if you're familiar with the Just My Code feature of the debugger, you'll get this external code frame when Just My Code is on, which is on by default. If, for some reason, you do want to go investigate what calls are happening in that collapsed frame, you can right-click on the call stack and choose to show external code. And when I do that, this is all of the mess that comes out. So I prefer to run my debug sessions hiding all of that external code from me and just seeing my code. You can also customize the call stack to fit your viewing needs. So right here, I can turn on or off different things. So for example, show parameter values is something that normally isn't on, so you would just see string URL here. But when I do turn it on, I can see the actual value of the URL in my call stack. So as you're investigating your code, you can start to see those values in line. So those are just a few tips about the call stack that can help you navigate and manage and make sense of your code faster. Now, I'm about to move to Visual Studio 15 Preview to show you 2 new things that we're introducing there. But before I do that, I wanted to point out this dialog right here that we broke on. Raise your hand if you've seen this dialog when you get an exception. I would hope every hand is up. Exceptions are something, as developers, we encounter all the time in our code. And sometimes when I get this dialog, I feel a little bit frustrated because exceptions are frustrating already, but then what am I looking at here? I really care about what type of exception it is and its message, but that's in the top part of this, and the rest of this isn't really needed for me right now. So just keep that in mind. Now when I switch over to Visual Studio 15 Preview, which I have up and running for us here, we are working on making improvements to that dialog to provide you with the information you care about in a smaller and compact way. This experience isn't on for default yet in Visual Studio 15, so you'll have to turn it on if you want to try it out. And you can do that by going to the Debug Options menu and scroll all the way to the bottom and check the box next to Use the New Exception Helper. So now I've turned on the new exception helper. I will stop debugging my other application. And I'm just going to restart this to make sure it'll work. I'm going to stop debugging and start debugging this to make sure it'll work. We're going to click error anyway and see what happens. OK, when I click error, this is the same error I clicked before. Notice something's different. It's the new exception helper right here. So this exception helper is pinned to your code. So as you scroll with your code, it will scroll with you. And it doesn't cover up your code anymore. We would try to put it in a convenient, out-of-the-way location right on the end and make it a more smaller, compact experience that shows you the information you care about. So you can see that this exception was thrown, this is the type of the exception, and this was the message. Something new here that you'll see is that we're showing you the inner exception. On the other dialog, I didn't even know that there was an inner exception, but right here in my face when I break, I can immediately see that there was an inner socket exception. And so that's, yeah, thanks. I got a comment once through Visual Studio Send a Smile that had a lot of exclamation points on it, and it said, "What is debugging without instant access to the inner exception?" And I agree, which is why we're working on improving this experience for you so you can navigate in the future multiple inner exceptions if you have them through this one dialog without needing to go into the details. And we hope to continue to make improvements to this and turn it on by default in future, like after preview. So that's one new experience I wanted to show you. And I'm going to move on to the second one, which is, once I get my WPF app back up here, I'll just move on to my next task. And when I click on my next task, I break on an exception. And that's because I have exception settings set to break when thrown still. When I like running with exception settings turned on, because it allows me to see and make sure that my exceptions are being handled properly as I go through my debug session. But there are some exceptions that are unfortunately not exceptional. For example, in this case, what's happening is that I'm trying to read the values from the registry just to set my user's settings. But they haven't configured settings yet, so I'm getting this exception being thrown. And there's like 50 to 100 of these. And I would have to continue past each one or set a breakpoint somewhere after this code is called and then turn on and off exception settings. But the new feature we're introducing is the ability to more finely tune what exceptions you're going to break on. So in the exception settings window, I can right-click on Common Language Runtime Exceptions. And we added this area called Edit Conditions. So when I edit my conditions, this dialog will pull up, and I can add a module name condition. So what's happening right here is it says module name not equals, and I know my library is a settings library. So I can use wildcards, or I can say settings library.dll. But I'm going to use wildcards and type settings in here. And so now I've set module name not equals to settings. So all of the .NET exceptions are going to break when thrown, except when the module name is settings. Now, I'll show you this by hitting continue, and you'll notice that I don't break on any of those exceptions anymore, and there was like 100 of them. So now when I click this parallel button, I don't break, but as I click error, it will break. So that's just one way that we're looking to improve your exceptions experience in Visual Studio 15 preview. I encourage you to try it out. Go download Visual Studio 15 preview, send us feedback, and let us know what else you want from us in the debugger. How can we help you be more productive? And yeah, so raise your hand if you're going to go download Visual Studio 15 preview and turn on the exception helper. Thank you all for raising your hands. I look forward to your feedback. I want this back on. OK. Thank you for clapping. I understand that you want to run away. But before you do, I want to tell you one way that you can help give us more feedback. So help us improve the debugger. If you go to this link, you'll get to a page where you can sign up. You can give us your email and what type of developer you are. And so this will make it so you can have the opportunity to give us feedback in the future and try out products directly from our debugger team. So we just want to be able to contact customers like you guys who are our fans and figure out what you want and what you need. And additionally, right after this session, out those doors, we're doing what we're calling a flash voting. So we'll have 3 questions for you, and you can meet our user researcher, Carl. If you turn your heads, he's already holding up the flash voting sign. And we're just going to take 3 minutes of your time if you want. We're going to ask you some questions, and you're just going to vote on your behavior and what you like more. Also, there's some resources here. And don't forget to complete an evaluation. Thank you so much for coming today. I hope you all the best of luck with your future debugging.